we are with respect to this course. And you know that when we broken down this course into 4 pieces, first thing first, we got the enterprise network, and we have a pretty good understanding of enterprise network now. We have pretty good understanding of classification and marking now. So these 2 pieces are done. Believe me, in our last lecture, we are going to combine all these concepts together to have a complete picture. Today, we are going to start congestion management, which is mostly known as queuing, right? And today's class is totally dedicated to this piece. So now, first thing first, let's try to understand what exactly the meaning of congestion management and why at the first place we need congestion management, right? So again, our favorite characters are here. We have Anjali here, right here, and we have Mr. Rahul, right? And now, from the previous class, Anjali knows at least one thing, that she can mark packets, right? And she is again taking the example of postal office service, where I am showcasing you several letters, right? And these letters have been marked by Anjali, right? The green color letters, or the letter which have green seal on it, it means that it belongs to the premium service. The yellow one belongs to the express service, right? And where there is no seal, those are actually for your regular service. There is no need of priority, or giving them somewhat little bit more priority than others. So white color is just your regular packets, and Anjali has done it, right? Anjali has marked these packets with these colors. But now the question arises, now what? Whose responsibility it is going to maybe take the green letter and deliver this on the priority basis, whatever the premium service they have, right? There must be somebody who is going to do this, right? And that is where we are right now. We know how to do the classification of the messages, right? We know how to put these green colors, red colors, yellow colors on it, right? So that they can be identified. But we are identifying them for what? At the end of the day, we should be taking these green messages first, right? And these green messages should be delivered as soon as possible, then the yellow one, and then the white one also, right? But who is that guy who will be doing all these things to us? So once we identify the packet, once we mark the packet, right? We need to think now, and that is what I'm going to explain you in the next board, that once my packets has been marked, right, colored, what I need to do with it. And here you can see that Anjali has come up with a great idea. She's saying that whatever the packets which are looking similar or which needs similar kind of service. For example, we have these green messages, and these green messages are actually the one which needs premium service. If that is the case, Anjali is going to put them in a special box, a special container, or maybe she's saying that I am going to put them in a particular queue, right? It is the same queue which you see in most of the malls or most of the departmental store. When you go and purchase something, then of course there are so many people just like you who are also buying the stuff from there. And they, when they go out from the mall, just before that, there is a queue so that you can do your billings, right? If that is the case, there are going to be many queues. So Anjali is just taking the idea from there, and whatever, because there are so many packets here, right? Just in any order these are, but we have marked them. But now the first thing Anjali is doing is that she is placing them into a particular queue, and she is naming those queues also. For example, she has placed these green color packets in the premium queue, right? And of course, the name of the queue, this queue is premium one. And then we have the express queue, and then we have the regular queue, right? So first, classify the packet, mark the packet. Once you have marked the packet, it is pretty easy to choose the packet and put those packet into some specific queues. And that's what we are doing right here, right? Now, again, the question arises, what's next? Once it is done, what I'm going to do next? So there must be somebody who is in charge of these queues, right? who will be guiding us that if this is a premium queue, if this is express queue, then in which queue I should go and take the packet first so that this message can be delivered at the destination as soon as possible. What we are trying to do, we are just trying to search for a logic, right, through which we can just extract or take a packet out means from any of this queue, right? And that is what is known as scheduling, right? We need to schedule these messages, right? And that is what is done by Mr. Rahul here. What Rahul is doing here. So if you see Mr. Rahul, Rahul has taken all the packets from the queue. And then you must be thinking, Mr. Vishnu, if that is the case, what these messages are doing? These are the new messages, right? If you go into the previous board, what Mr. Rahul is doing, he is taking two messages from my premium queue, which was the green queue I had, and then he is taking the messages from the yellow queue, and then two messages from the queue. Which queue? The regular one, right? It means that whoever is going to deliver them, these green messages will be delivered first, then the yellow one, and then the regular ones, right? It means that who exactly is doing this logic? This logic is performed by Mr. Rahul, and I can say that Mr. Rahul is scheduling or busy in scheduling all these messages, as simple as that, right? And by the way, whatever we are seeing in this example, the postal office analogy, right? We will be seeing the same thing again, right? For example, when all of these queues get empty, of course, there is no shortage of the new messages, and the messages are coming again and again. We are busy in classifying them. We are busy in marking them. Once this has been classified and marked, they again are going to be placed into this premium queue, express queue, or maybe your regular queue. Once that is the case, again, scheduler or Mr. Rahul will be seeing all these messages. And then if he sees these messages in the premium queue, it is going to extract the premium one and deliver it. Then it is going to, and if the premium is over, then of course he's going to go to the he's going to get the express one, and then he's going to deliver it. And then we get the number of regular messages, as simple as that, right? So whatever we have discussed till now in last 10 minutes, we will be seeing exactly this thing again and again with different tools of quality of services, right? Uh, because you all know that we have been doing quality of services from year 2000 and we are in 2024. So it's a journey, right? If I'm teaching you a tool, the quality of service tool, you can definitely see that Vishnu, this tool doesn't make sense. And then I'm going to say that uh, please try to understand this tool was developed in 2000 and maybe 5, and at that point of the time the requirements were different. But if we can understand the journey, then we can understand why behind a lot of things. Okay, so the whole sole idea of congestion management, the whole sole idea of queuing is that whatever we have classified till now, we are just identifying them or placing them into different queues, right? We are giving those queues as a name, maybe premium, express, regular, and then we need a scheduler who is going to take these messages out from the queue and deliver it to the destination. This is the whole sole purpose, right? And this is why we need queue or congestion management. So first classify the messages, right? Place them into the different queue, and then there must be somebody who is taking out the messages based on your requirement. If it is the premium one, it should go first. If it is the express one, it should go next. Regular is going to get the regular delivery. As simple as that, right? Now, if I go to the next board, we will be talking about whatever the concept we have seen in the postal office analogy, we will be seeing with respect to router and switches. Again, we have router number 1 here, we have router number 2 here, and I would like you to brainstorm again on this picture, right? If you place yourself right there, you will come to know about many concepts, right? So what exactly is happening here? Again, we have lots and lots of messages here. And interestingly, from the last class, we know how to classify them and how to mark them. The meaning of marking is that the green color message will be carrying the service which is premium, right? The meaning is it just like an ambulance, right? If we have a traffic jam and of course ambulance came, everybody should give the way to the ambulance so that it can go, right? And that is what the my green messages are. They should receive the absolute premium service, right? Whenever they come, irrespective of the fact that what we have with respect to routers or what we have on these routers, these green messages would be delivered as soon as possible, right? But my problem is by default, if we do not use these queuing mechanism, right? Whatever the queue which we were discussing in the postal office analogy, router has only one queue, and this queue name is FIFO, right? First in, first out. It means whatever you are sending, means if this is the regular packet, which is of white color with no tag, it is right here. Then we have the green message, which is right here. Then we again have the uh, white message, which is the regular, which is this one. And then we have the yellow one, means if I mark this 1, 2, 3, 4, I have messages 1, 2, 3, 4 here. And then again, the fifth one is my empty packet or my regular message. This is 5, then this is 6. You can mark them, right? But the interesting thing in, first out logic is whatever I am getting as my packets, right? Doesn't matter if I have marked them or not. Everything is in just one queue, right? Suppose this queue length is 12. And now the question arises, Mr. Vishnu, what is the meaning of queue length 12? The meaning of queue length 12 is that it can hold 12 different packets. Then you be thinking, Mr. Vishnu, this should not be the definition because packets can be of variable length. One packet can be of 1500 bytes and the other packet can be of 100 bytes. If packet is of 100 bytes and if the queue can store 12 packets, then the queue length is going to be 1200, right? But if again, if the queue length is 12 and it can store 1500, then definitely I can say that it can, if I talk about 1500 bytes, right? It is going to give me 1500 into 8 bits, and here I am going to have 100 into 12 into 8 bits, and of course this value is going to be way more as compared to this one, right? Because if I'm talking about bytes, the number of bytes I am holding in the same queue are going to be different, and that is where the point come into picture. That if I say the queue length is 12, irrespective of the packet, it is going to store, irrespective of the packet length, it is going to store 12 different packets. Doesn't matter whether that packet is going to be of 100 byte or 1500 byte. And you must be thinking, Mr. Vishnu, how it can be possible? It can be possible, right? How? For example, I have, say, suppose 5 different messages. Just try to understand this. This is important. So what I do is I store all these 5 different messages into 5 different buffers. Buffer is just nothing but the memory inside my router. Okay. So this is my buffer number 1, this is my buffer number 2, this is my buffer number 3, this is my buffer number 4, or this is my buffer number 5, or maybe this can be the entire memory, right? One memory. So what I can do is I can have one packet in buffer number 1, and this packet can be of 1500 bytes or 120 bytes, but this is my packet number 1. This is packet number 2, 3, 4, 5. And to store a 1500 byte message, this buffer is going to be 1500 byte. To store a message of 100 byte, this buffer 2 is going to be maybe only 100 bytes, right? Or these are the contiguous memory locations. So we do not need to talk about it. But the point here is the packet gets stored into the bucket, into the buffer. But if I talk about the what we can say queue, and this queue length is also suppose 5, right? Or maybe 6, or maybe 5, right? Then Actually, inside this queue, we do not store packets. We actually store location of the messages or the packet, right? For example, in memory, the address or the location of the packet number one is say 1234. I just need to store the location or the address of this buffer. And this is very, very interesting point. Whenever I say I have a queue length of 5 or 6 or maybe 64, the meaning is it is going to store 64 packets, but it doesn't actually store actual packet. It store the address of the message, right? So that is why I am saying that this queue can store 5 messages. Doesn't matter if it's of 1500 byte, 1200 byte, 100 byte. Doesn't matter. It is going to store 5 different packets, right? But I do not want to explain all these concepts again and again into this board. So I am explaining you this once. And when I introduce the concept of queue, just try to understand. Again, I am repeating. The queue length 10 means it is going to store 10 different packets. And if I'm saying that I have a queue length of 12 here, the meaning is I can store 12 different packets. And the concept of FIFO is whoever come first, it is going to go first. As simple as that. It will be the one who will be going out from this queue first. As simple as that. Okay. Just wait a minute, guys. This. So now, what is the problem with this approach? First in, first out. The approach is simple. Who, whoever is coming first is going out. But the problem with this is that the packet can face more delay and eventually the more jitter value. And why it is the case? The problem is suppose a voice packet comes just after these 12 packets. There is no doubt about it because of the FIFO logic, first in, first out logic. Once these 12 packets goes out, then this packet will get its chance to go out. And it's a problem, right? Now, what we can do to just remove this delay problem, we can have smaller queues. For example, right now I have 12 queues, 12 packets in the queue, or the packet length is, sorry, the queue length is 12. If I have only queue length of only 4 packets, it means that whenever a new voice message come, right, it it has to wait only for uh, uh, 4 packets, right? It doesn't need to wait for 12 packets to go out. But the problem is with both the approaches. If we increase the length of the FIFO queue, then the delay and jitter increases. But if we decrease the length of this FIFO queue, the problem is this queue can store only 4 different values, right? And if we have lots and lots of packets which are coming, then these packets will be dropped because they do not find any space. They do not find anywhere to go out because they cannot be placed into the queue. And if they cannot be placed into the queue, we have to drop them, right? So this is the by default method, by the way, guys, right? If you do not do anything on your router, it is doing first in, first out. It means that it is not suitable for the traffic which is highly prone to delay and jitter, or which is affected by delay and jitter. And when we were discussing about traffic types, there is one type which is the voice traffic. The little packets, you understand them, right? And those are going to be having a lot of problem if you do the first in, first out, which is the by default method. And if you do that, your voice traffic is going to suffer a lot, right? But it doesn't matter, means if you are understanding a concept, it doesn't matter it is going to create a problem or not, but we are here just understanding this concept first in, first out, right? Although we have understood the problem associated with it, but this is just one of the approach, which is the default approach, right? And the whole sole point of this course is to just change this FIFO into something different, right? And one more thing, if you do not do anything, there is only one queue which we have, which is your by default queue, which is your software, which is also known as the software queue. Okay, as simple as that. Now, if I go into the next board, what we are doing as a part of this congestion management now today here is, see, if I get all these messages on the gigabit 0/0 interface of this router, right? And these messages are in any order, but we have classified them, we have marked them. If we have classified them and marked them, now what we are doing here as a part or as a change to this FIFO is, and this is the whole sole purpose of this lecture, is that we will be creating different queues, right? Queue number one, queue number two, queue number three, right? And this queue number one is going to have maybe say premium services packet or maybe the voice packets. And that is why I am introducing green packets inside Q1. In Q2, I am going to put the express services or maybe my SSH traffic, telnet traffic, right? And I am putting it inside the queue number two, which is my express queue. And the last queue is definitely the one which doesn't require much service. That means that those are my regular packets, right? Once I have created these three queues, previously, by the way, on the router, I had only one queue, which I was calling software queue. And the logic of this queue is first in, first out. But now I have three different queue, Q1, Q2, and Q3, and I have placed my messages inside these different queues. Whatever we have discussed in the postal office analogies, I am showcasing you how exactly is happening in the router's world, right? So this router is having now three different queues. Who is going to create these queues? Absolutely you, the network administrator. How? I will be letting you know. But first thing first, let's try to understand. Once we have these three queues, and once we have placed our messages into these queues, right? We need somebody who can now schedule my messages, who can schedule my packets. And the job of this scheduler is, right? And I have explained it that the quality of service need, whatever you have in the queue number one, it should go first. And that is why this guy is just taking the packets from the queue number one and placing them onto this interface. Maybe this interface is 0/1. Interesting, right? All these four packet number one, two, three, four, as you can see, the scheduler is taking them and it is putting on to the 0/1 interface, packet number one, packet number two, three, and four. Then we have the yellow one, maybe five, six, seven, eight, and then we have the one which doesn't need much quality of service. Although I am showcasing only two, but try to understand these messages are also going maybe 9, 10, 11, 12, as simple as that, right? So the most important thing here is now which we need to understand how this queuing process happen, how you are going to create these queues. And if you can create these queues, how you are going to schedule them, right? That the priority ones should go out first. What are the different iOS tools given by Cisco routers to you or maybe switches to you? How you are going to use them? But the overall idea is going to be same. And thank you so much, Bhagat, for raising your hand. Please do ask your question. Mr. Bhagat.
Hello, hi, sir.
Hi.
So actually, let us assume that green packets, green one having like 10 packets,
Mm-hmm.
but Q1 let us store only 4 packets.
Yeah.
So
So you are saying that
how it will?
the
Yes,
Q1 length is basically
yes,
your 4 packets, right?
yes,
And
yes,
then it is getting the 10 packets.
yes,
Okay. So it is always the case. And if I presume that other queues are also filled, right?
yes, yes,
Let's presume them. Otherwise, see, we are till at this point, we are in no situation to explain this question. But let me, and by the end of this class, you will be knowing it for sure. But let me try to explain this. Once we have this, means if suppose we have all these 4 packets already there inside my Q1, and we have another 10 packets which are coming, right? And the problem is that my interface, which is taking these messages, is also filled. And that is what we known as the period of congestion. If that is the case, even if I want, see, the 10 packets, whatever is here, right? They cannot go into this Q1 until and unless I send some of the messages over gigabit 0/1. And by the way, this is known as the hardware queue, which I'm going to explain you in the next board, right? So if this queue is not empty, right, I cannot put these 10 packets inside this. If that is the case, then unfortunately, we need to drop some messages. We need to drop this, right? And if these packets are dropped, then if the TCP is running, of course, it can ask for retransmission. If these are your UDP messages, these are just gone. And that is what exactly happens when router meets, or when router basically gets congestion on on this interface, right? Where it cannot take out something from the queue. Queue gets filled, more messages are there. There is no space for them, and those messages are going to be discarded. As simple as that. Mr. Bhagat, any other question you have over this?
Can we increase the buffer size like Q1?
Definitely, and this is
Is
the
it
property of every scheduler or the queuing tool, which we are going to discuss in this class. So whatever you are asking next 5 or 6 board question. Believe me, after this class, all the questions, whatever you're asking right now, will be gone. Mr. Bhagat, we are good?
thank you, sir.
Perfect. So now I think with respect to this point, we have just understood only one thing here. Router will get all the classified and the marked packets, right? And as an administrator, because we know what service to give these packets, and that is what is known as quality of service, we will be making different queues. I am just giving example of queues with length 4. Believe me, different tools have different queue lengths. It depends on what administrator wants to use, right? Once we have these queues, we need a scheduler who will be taking these messages out and putting them on the router interfaces. This is what we just know till this point. Now we will be going little bit more into the router to understand the question with just Mr. Bhagat. And I think there are a lot of question in everybody's